Hello and welcome to another Evil Equations video. I am an amateur mathematician and creator of foul-looking math expressions. I do not have any fancy degrees nor formal education, and everything I know was self-taught. But I do enjoy learning advanced mathematics as a hobby. So when I learn something new, I often like to use it in my Evil Equations. Recently, I have been introduced to a Polish mathematician, Stefan Banach, who was a major contributor to contemporary mathematics in the early part of the 20th century. He is largely credited with the development and formalization of functional analysis, which deals with things like vector spaces. And as is the tradition of this channel, I made an evil equation using some of this type of mathematics. So if you want to give this one a whirl, by all means go ahead, pause the video and try to solve it. Before, of course, I explain how this atrocity was created. Alright, so for this equation I chose to use vectors because after all, I wanted to use some basic Banach space ideas. Consequently, this meant I would be using norms. Now, a norm of a vector can usually be considered to be the vector's length, which means we can use the Pythagorean theorem. Pretty straightforward, nothing too scary yet. Now, this expression can also be depicted in terms of a sum. The v here represents the vector component, and this d up here represents the number of dimensions of our vector. We can of course have as many dimensions as we choose. I decided to go with infinity. Now, the other thing is that we can have other types of norms. Thus, we replace the 2 with a p being anything from 1 to infinity. I'm sure we can have other values as well, even complex numbers, but that's real dark magic, so we will avoid that in this video. We also use the convention of putting the p in the subscript of our double line parentheses to indicate which norm we are using. Alright, we have the LP Banach space with a vector. I know, functional analysis is supposed to be about functions, not just vectors, but I thought I'll keep this one simple. So the next step was to actually create this vector. And of course, it had to have infinite dimensions. I decided to use this famous geometric series. The idea was to create a vector whose components are 1, 1/2, 1/4, 1/8, and so on. And so this summation was exactly what I wanted. In order for this to work, I decided to use E hat. E hat refers to individual unit vectors, which correspond to each coordinate dimension for n dimensions. Sort of like I hat, j hat, and k hat, except we can have an unlimited amount. This lets us express our vector using the geometric series summation like so, and we got our vector. Now, figuring out the expression for the norm is pretty easy. We can just use the summation term inside here like so. We can also make our k into 0 to make our math cleaner. And I do hope this still works. Well, at least it should for this specific case. Perfect, almost there. For the next step, I decided to divide one by the other, giving us the famous cheese maneuver, and making one be the result. I then decided to add this minus here in order to turn the 1 into Euler's identity. And this looked great to me. Exactly the kind of math weirdness I enjoy. Vectors, infinite summations, some bizarre norm properties. Lots of fun. I was satisfied. Still, I thought this too was a little bit boring, so I just changed it into this thing. Perfect. Another insane math experiment for all the math nerds to enjoy. An evil-looking equation that gives us the e pi I. And what a fantastic bit of madness. I'm certainly glad I ran into the idea of Banach spaces. It sure made me brush up on some concepts regarding vectors and such. I might exhibit this equation on Etsy, so keep looking for evil equations in the Etsy search box. Hope you guys enjoyed this video. Like, subscribe, and I hope to see you all in the next one. And have yourselves a great day.